Good evening. Yeah, you can see the PowerPoint, right?
Yes.
Okay, sweet. Sorry, it doesn't look normal for me, and it was freaking me out a little bit. Good evening, friends. Welcome to Math 98, Section 1. This is week 3, where we are looking at decimals and averages, and at some point I'll actually reflect that to show the other mathematical name for averages, which is mean, M-E-A-N. And I'll change it to reflect it because that's the only way your homework is ever going to talk about it. Your homework's not going to ask you for the average, it's going to ask you for the mean. But they are the same thing. So we'll go ahead and look at tonight the PowerPoint. We'll work through some stuff. We'll play Beat the Teacher. We didn't play Beat the Teacher last week, did we?
No.
No. Okay. Beat the Teacher is a terrible, terrible game that I should not encourage you to play because speed's not necessarily our friend, but we're going to do it anyway because it's entertaining for me. So we'll play a little game called Beat the Teacher as we work through our PowerPoint. And then I'll share some closing thoughts and send you on your way. Before we get into that, any question from last week?
No, sir.
Okay, so last week's the most consistently missed questions from last week tend to be the remainders, and that's mistakes that are made because people frankly don't listen to the PowerPoint. Sorry, that sounds really bad. It's not that they don't listen. It's that they I don't know why I'm struggling to say this. Here's the short version. The people who tend to be successful on last week's lesson are the ones who listen to the presentation or work through the PowerPoint. They can download it and work through it on their own, simply because they get the reminder that we're looking for remainders, not decimals. Whereas for those who don't, are so used to solving a division problem and using decimals that they instinctively do it anyway. I one time had a student take a picture of her work showing, because I used to assume until this student fixed it, I used to assume that when a student had a decimal as an answer, that they had just used a calculator, which was a horribly, not trusting thing. But it was still where my instinct was. And this girl sent me a picture of her work done longhand. And that was when I realized that she was doing what we have all been taught since we were like in 5th or 6th grade, to put a decimal point and add zeros and solve it till it's done. And so I think for most of us, that's just instinctively what we do. And so those are the most commonly missed, not because people know, they just don't realize that that's what they're supposed to be doing. So, wow, that was an awkward 5 minutes. I'm sorry. Let's go with this question to start us off tonight. And as Chelsea is joining us once again, good evening, Chelsea, and thanks. As Chelsea is joining us once again, she gets to answer all the questions. Yay!
Yay.
Yeah. I hope you could all, sense and feel the enthusiasm in Chelsea's yay. Palpable. So here's my question for Chelsea. Chelsea, if you had to explain a decimal to someone who didn't know, how would you do it?
I have no clue.
Right?
You would have to explain to them what math is and then probably what a number is and then and then go into the decimal if they grasp the concept of what a number is.
Well, let's go ahead and assume they have that aspect. Let's go ahead and assume that they've worked themselves up through 3rd grade math. Fourth grade is when they start introducing decimals, I think.
Okay, well, I would assume that you could say that a decimal is a way to explain something smaller than a whole number.
I like that. It's true. It's true, which is why I like it. And it's thoughtful. Now we've just demonstrated, and again, thanks Chelsea for being the guinea pig and coming up with
Taking one for the team.
yeah. So here's the thing, and I may have said this before, I may not have. For the purposes of, I mean, depending on which study you look at, there's various levels of understanding. For me, I tend to think of our levels of understanding as there's 3 levels of understanding. Level 1, you can do it if someone's helping you. Right? So you might have to have someone remind you of the steps of the process. That's how you're going to get it done. Number 2, is wow, sorry, that you can do it on your own. You don't need anyone else's help. You can do it on your own. The 3rd level of understanding is you can explain it to someone else. That the gap in between being able to do it by yourself and being able to explain it to someone else is a bigger gap than you think it is. There's a lot of things that we understand instinctively, some of them, and simply because of sheer repetition for the others, things that we understand but we've never had to explain it. And so we stumble with how to explain it. Chelsea, you did actually a fine job explaining that a decimal is something less than 1, right? Other things that I've commonly heard here, it's money. A lot of people use that as the way to explain a decimal. Oh, it's money, which it's not inaccurate. It's not inaccurate. It's not 100% accurate. Obviously, it's the little dot, they say, which is also true. It is the little dot, although that doesn't really explain what it is. It just explains how to identify it. So these are all things that I hear, and again, I get it. Most of us would recognize a decimal if we saw it, but having to explain it to someone else is a different beast altogether. So here we go. A decimal is a piece of a number. Okay, it's written using a period, a dot, a point, right? Call it what you want, it's that. And again, the difference between this and the multiplication symbol is that this sits down on the line, right? Believe it or not, a decimal is simply another way of writing a fraction. Sure, why not? So here's a question for you to think on, and we'll let, if Chelsea wants to venture an answer, she's more than welcome to. But the rest of you, consider it. Which do you think is more accurate? A decimal or a fraction?
Well, wouldn't they be equally as accurate because they're just expressing the same thing?
There it is. It's funny because most often people will pick one. Decimal often wins that argument because people think, oh, but it's a really long. Except here's the thing: every decimal can be expressed as a fraction, and vice versa. You can express every fraction as a decimal. Okay, on a simple version, 1/2 or 1/2 can be written as 0.5. Right? That's 1/2. Every decimal can be expressed as a fraction, and every fraction can be expressed as a decimal. Now, I pointed out 2 ways to write 1/2. You can write it as 0.5 or just 0.5. Is there any mathematical need for the 0.5?
No, it's understood to be there.
Yeah, which is what I found as I've looked over it and tried to find a mathematical reason why we would put 0.5. I couldn't find one. So what I came up with as to why we might do it is because a decimal is a very easy thing to miss, right? I have seen many, I mean, even as I work in this class, as I go into like your guys' assignment, I'll see something and I think it's a fleck on my computer screen, only to turn out it's a decimal. Or I see it and it's a decimal, and I, go to rub and make sure it's not just a fleck, and it's a fleck on my screen. So a decimal is very easily mistaken. Because we don't typically write the number 5 as 0.5, when we see that 0, it's a bit of a heads up. Hey, something's different about this. So we look at it hopefully a little more slowly. That's all it is, right? To me, that's about the only benefit of putting the 0 first. All right, parts of a decimal. There are 3. Excuse me. There is the whole number, which is whatever is to the left of the decimal point. There is the fractional part, which is whatever is to the right of the decimal point. And then you have the decimal point itself separating those two parts. Now, like I said, most of us can spot a decimal when we see it. Where we are going to run into trouble and struggles is reading a decimal. And there's a couple of things that we need to point out. Now, we remember this was our setup, right? The same pattern, 1, 10, 100, 1, 10, 100, 1, 10, 100. The no name, the thousand, the million, the billion. We remember this from a couple of weeks ago, yeah?
Yes.
Okay, so sticking with our town theme, and especially if you want to go, like stereotypical old school movie kind of theme, every town's got the tracks. And you've got, the good side of the tracks where the houses are big and pretty, and then you've got the other side of the tracks where they want to be like the big and pretty side, and so their houses look similar, they just tend to be smaller in size, right? Think of decimals the same way. There are going to be a lot of things that are the same. There's also going to be some differences. So take a look at the information that I just put on the screen. And go ahead.
Screen didn't change.
Really?
Really?
So what are you looking at right now?
What is a decimal?
Really?
Really?
How long ago was that one? You didn't see the parts of a decimal thing?
Nope.
And you're not seeing it now?
Not at all. I'm seeing what is a decimal, and I'm still seeing your cursor move around, but that's what I'm seeing.
So awesome. It's like the best day ever. Okay, what are you seeing now?
Parts of a decimal.
Okay. Now?
Numberland.
Okay, that was weird. Not really sure what happened there, but it appears to be fixed. Okay, so now, now everything I said just makes way more sense.
Completely.
Yeah, now you're not like, this dude's an idiot. No, I'm not. I mean, I am, but I'm not right now.
Woohoo!
Right? That's the big news of my day. All right, so there are a lot of things that are the same on the right side of the decimals on the left. But like I said, there are a few things that are fairly different. So what are some similarities you see here, and what are some differences you see?
There's no, I don't know. My brain's not functioning.
Oh, don't worry. I understand that one today. So I want to start out with some of the similarities. The naming
I think it's throwing me off because it's going,
the
it's
other direction.
not, yeah, it's just flip-sided.
Okay, so you just discovered one of the differences.
Yes.
Most of the information is the same. One of the big differences is it's a mirror image of the whole number side. So the ones place, instead of being on the right of each 3-digit number, it's now on the left. The 10 is still in the middle. The 100, instead of being on the left of every 3-digit period, is now on the right. Okay, so that's the thing. The decimal side is a mirror image of the whole number side. Okay, that's one of the first big changes. Some things that are similar, your naming is similar, right? We still have a ones place over here. We still have a tens place. We still have a hundreds. 1, 10, 100. That's the same. This is a no-name house. This is a no-name house, but with a TH. This is thousand. This is thousandth. Okay. So again, the names are similar. We've just tacked on that TH to give it that little bit of difference. Okay. Million, millionth. And then we have, well, what we already pointed out. Now, there is one huge difference, and it's funny because I'm going to say it, and you're going to think I sound like an idiot. And yet, over and over again, this is a mistake I watch get made. And it's this. Notice that our first house has no ones place. Now, we left room for it so we could draw attention to it. But what you need to understand is the first digit following the decimal point is the tenths place. There's no such thing as the oneths place. And that's where people usually think I sound foolish. Because they're like, once place. Dude, that doesn't even sound like a word. And you're right, it doesn't. Because it's not a word. And yet, so often, people will be asked to identify place value, and they'll treat the number as though that first digit is the oneths place. So it's good that we recognize it, but we need to remember it. It's not enough to just recognize it when someone is saying it as being wrong. We need to recognize it when we're simply staring at a number. Now, the only other thing I really need to point out here is this idea, and it's the reminder of how to read a large number, right? It's just, you're going to kind of follow the same pattern at first. So if I were reading, this number over here, just the whole number part, 465 billion, right? We say the 3 digits, we tack on the name, 200 million, 134,300. Okay, when we add in the decimal, then it becomes and here's where this gets confusing for people. The first thing you're going to do is you're going to look at that number and you're going to say, okay, how would I read that number? If that's just a number, 65789, how would I read that number? So how would you read that number?
I'm not even going to try.
Not as a decimal. If I were to just take 65789, and if you open up your chat, you'll see the number typed. For those of you not, I'm just retyping 65789. Ignoring the decimal point, just 65789. It's funny. How would you, just a normal number, ignore the decimaliness of it, right?
Oh, well then 65,879.
Right. Oh, I flipped the numbers. But yes, what you read what I wrote, that's correct. What I meant to type was 65,789. So that's the first step. The first step is, look, what's the number that's there? Just read it. The kicker comes in having to identify we have to do something to set it apart as a decimal, and isn't enough, right? If I read 465 billion, 200 million, 134,300, and 65,789, you would just assume I was reading two numbers, a really big number and then a slightly big number. You wouldn't think I was reading a decimal.
So would you end it with thousandths?
So that's where we come to step 2. And you're close. What you have to do is you have to identify the place value of the final digit. So you start here. We know that one is tenths, then hundredths is the 5. This 7 is in the thousandths place or the 1,000ths place. The 8 is in the 10,000ths place, which makes the 9 in the 100,000ths place. It's this last one that we care about. We don't care about any of the ones that come before it. We just care about that last one, because it's that last one that we're going to tack on to the word name to set it apart as a decimal. So it's 65,789 hundred thousandths. Does that make sense? Ish.
Somewhat. Just write that stuff as a fraction.
Well, and that's the funny thing. So, I mean, if you were to write that as a fraction, it would be 65789 over 100,000.
See, that's so much easier. I'm just
Right.
saying.
Oh, don't get me wrong. Fractions tend to be much easier for people to read. But
And you're not going to hear me say that because I hate fractions.
I know.
But
And
I would say that.
I think fractions get a bad rap. I think people, if they, understood just how similar they were to decimals, they wouldn't dislike fractions so much.
My teacher made them much more complicated than they needed to be.
I know. I'm sure my students say the same thing. And they are difficult to explain. I hated fractions as a kid, but man, I love them now. I think we just had someone else join us. Brenda just joined us. Welcome, Brenda.
I'm not alone.
You're not alone anymore.
I will say, yeah, I won't say anything. We're going to keep going.
So what did you say? What did I miss in the last 2 minutes?
Well, that's just it. It's not the last 2 minutes. It's the last half hour.
Oh.
Yeah, so I had to adjust the time, which I listed in the announcement. I just forgot to send the email.
Awesome.
Too late to send an email. So you've missed the first half hour. Now, the good news is,
Thanks.
I know, it's super awkward. The good news is the first half hour just kind of covers what you're looking at on the screen. What is the decimal? How do you read the decimal? The key to reading the decimal is treat it like a normal number and then identify the place value of the final digit. So we're going to skip that. So if this is my number, 2.435, and all I have to do is identify the place value of the final digit. So ladies, what is the place value of that final digit?
Thousandths.
Okay. That would be correct. Right? Remembering, and this is where, again, where we tend to hurry and rush through it. There's no oneths place. So the first digit following the decimal is tenths, then hundredths, then thousandths, or 1,000ths, but we tend to just say thousandths. So after that, it's just a matter of reading the number and adding on the place value of the final digit. So it's 2 and 435 thousandths. So this one's easy. What would this one be?
10.
Well, tenths.
7 and 4/10.
Yeah, 7 and 4/10. And then this last one.
3 and 89 hundredths.
Yeah. Okay, again, it's just a matter of identifying that last place value and then reading the number. Now, where we're going to see a lot of mistakes come with this, we're going to see a lot of mistakes come with the decimal point. We love to say things like 7.4. We love to say things like 3.89 or 3.89. We love to say it because it's easy and because everyone understands us. Okay, it is socially acceptable to read a decimal that way. It is, however, mathematically incorrect. A decimal, when you're reading it as a number, is always read as an. And so you can't, the point, while it's socially acceptable, if you choose that as an answer on your homework, you're going to go ahead and get it wrong. All right. Rounding decimals. I'm not going to lie, the rules are the same. Okay? Just like we rounded whole numbers, we're going to round decimals. There is one change, and it's what you do after you've rounded. So if I have 6 and 484 thousandths, and I want to round it to the nearest hundredth, the first thing I'm going to do is look at what digit is in the hundredths place.
The 8.
It's the 8.
No yawning.
Nope. That was not a yawn. That was something else entirely. I got in trouble for that once. I had someone listen to a recording and like, you need to not do that. I'm like, I'm sorry. Anyway, my classroom's warm. I hate that about my classroom. So the 8 is in the hundredths place, right? So that's the number that has the potential to change. The 4 is the one who's going to make the decision about what happens. The 4 says what's going to happen to the 8.
It stays.
It stays. Okay. Now, last week, what would we do with the 4? It would become
Turn it to a 0.
It would become a 0. That's where you get different with decimals. When the rounding happens to the right of the decimal point, instead of becoming a 0, it just falls off. So it becomes 6.48. No 0. Just 6 and 48 hundredths. Now, having said that, on your homework, if you choose the answer choice that is 6.480 instead of 6.48, am I going to go in and give you credit? Yeah.
No.
No, I am. I'll go in and give you credit. Because I argue over and over again that mathematically there's not a difference between 6.48 and 6.480. Now, you could argue that there is, and I understand that argument. I just think it's hogwash. I think it's a nitpicky, dumb argument, and I'm not having it. That's where I'm at with that. So if you choose the answer choice that says 6.480, it's going to mark you wrong. Understand that. I'm going to go in and say you're fine. I mean, there's not a lot of options for that on your homework. I think there's 1 or 2 questions where you could make that mistake. It doesn't happen very much, but that's where we're at there. Okay. Yes, you should drop it. Yes, that's the rule. If you don't, okay, you don't. We teach when we teach division that you can add as many zeros as you want after a decimal and it doesn't change the value of the number. So that's why I feel comfortable doing what I'm doing. All right. So here we have 7 and 37 thousandths, 7 and 37 thousandths, and they want us to round it to the nearest hundredth. So ladies, what do you think that answer would be?
7 and 4 hundredths.
Yep.
Okay. So 7 and 4 hundredths. right? We simply drop the 0 after we've changed it. That's rounding. All right, here's a fun question. Where's the decimal in this number?
Behind it.
At the end of the 7.
Okay. I'm not going to lie, ladies. Kudos on that. Most people don't get that. I often hear, well, there's not a decimal, which is technically correct. There's not a decimal written there. I also get people who just want to put the decimal somewhere. Some tell me it's before the 4. Some tell me it's between the 4 and the 8. That's great, except if there's no decimal there, you can't just put one there because you feel like it. Okay. However, a decimal is a fixed thing, which is what I want you to understand looking at this. There's one place that if you're going to put a decimal, you can, because technically it's always there. We just don't choose to write it most of the time. And it's following the ones place. The decimal always follows the ones place. So anytime you're looking at a number, you simply find the digit in the ones place. That's where the decimal goes, next to it, to the right. Okay, and then you can add zeros all day long and do whatever you want to do. Okay, that comes in handy when we're having to divide. Excuse me. So there you go. That's what we got. All right, what's the easy thing for adding and subtracting decimals?
Line up the decimal.
Okay, line up the decimals. Now here's the thing. The truth is that the rules for adding and subtracting decimals are the same as the rules for adding whole numbers. The rules for adding whole numbers was that you line up the place value, right? Well, when you line up the decimals, you are lining up the place values. This 2 is in the ones place. This 5 in 345.3 is in the ones place. Okay, this 5 in 2.567 is in the tenths place, and that 3 is in the tenths place. Well, when I line up the decimals, oh look, my 5 and my 2 and my 5 and my 3 have magically lined up. Okay, so it's easier to say line up the decimals, but the rule isn't changing. You're still lining up place value. And then you simply add or subtract like normal, right? So 7, 6, 8, 7, 4, 3. Once you've done that, decimal point drops straight down. Okay, it just slips into place. Okay. Given a number that has no decimal, this is where you can revert back to lining up your place values. Ones place, line them up. Add a decimal, add a 0, do the math. Okay. All right. Multiplying decimals, what's the rule?
I don't remember.
Multiplying decimals gets trickier. Chelsea, you got an idea there?
Oh, not likely.
Fair enough. Here's my favorite thing about multiplying decimals. Are you ready? It's that you get to ignore the decimal. Okay, with this, you want to look at the longer number, not the bigger number, the longer number. Okay, the longer number is not always going, is not always going to be the bigger number. In this case, we have 2 and 45/100ths, and we have 134.3. The first one has 3 digits. The second one has 4 digits. The second one's going on top. And here's where we get to start ignoring the decimals. Because where with addition and subtraction, we lined up place values, with multiplication, we're not. We're lining up final digits. So we're going to line up the 5 and the 3 and then everything else. Okay? Then we simply ignore the decimals and do the math. Now,
I think I remember. Then you count how many numbers are behind the decimal points.
there it is.
That's what I was going to say. You just count the decimal place values and move it over that many.
Yep. So once we go back up to the top to where we started and we say, okay, how many decimals or how many digits appeared behind the decimal in our problem? Well, we had 1, 2, 3. So there has to be 3 in our answer as well. So we start over here at the right, 1, 2, 3. It's going to go in between the 9 and the 0. And then you're done.
I think I felt a brain cell come back to life.
Right? That was kind of nice, huh?
It hurt.
I figured you'd remember that part. That's the part most people remember.
I haven't used that since grade school. It hurts.
I know.
The cogs are working again.
Right?
It's rusty.
A lot of dust coming off there.
I'm pretty sure I just felt some come out my ear somewhere.
All the joys of math. All right, so here's where I'm not going to test your actual multiplication skills. I'm just going to test your placing decimal skills. So the number is 2 3/10 times 6/10. And it gets me something that involves the numbers 1, 3, 8. Where does my decimal go?
Between the 1 and 3.
Yes. Because we have 1 there and we have 1 there, so we got to have 2. Now, another way to look at it, another way to think about it, I love estimation. The longer I teach, the more I love estimation. I hated estimation when I started teaching. Now, I absolutely love it. My reason for absolutely loving it is because you can estimate and figure out about what your answer is going to be, and that's going to take care of where you put your decimal, which is mostly just a way to kind of check whether or not you were right, okay? So, for example, here we have 2.3 times 0.6. Well, the truth is anytime you multiply a number by less than 1, then your number is going to get smaller. So if I have 2.3 and I'm multiplying it by 0.6, my only options are 138, 13.8, and 1.38. I guess it could be 0.138. But anyway, so I like to estimate to kind of get an idea of where my decimal point should go. So here we have 54.79, or 54 and 79 hundredths times 6. And it gets us that. Where's my decimal point go?
Between the 2 and the 8.
Okay. What do you think, Chels?
Between, oh wow, no, because technically,
No, it'd be between the 8 and the 7 because the decimals go behind the 6.
well, yeah, that's why I said you'd have at least.
So there's only 2.
But I don't know.
So here's where, see, this is where I love estimating. This one, it works easier because we have 54, which, 54 and 79 hundredths, which is pretty close to 50 to 50. And then we have times 6. So 50 times 6. Well, 6 times 5 is 30. Add a 0, it's 300. My answer's got to be somewhere in the 300 range. There's only one place to put that decimal to make that true. And it's in between the 8 and the 7.
I was fixing to say, after I said that, I was like, wait a minute, no, that's basically like almost 55 times 6.
Yep.
Estimate that.
And that's where, you don't have to rely on estimation. And there's problems like this. Estimating gets tricky because decimals and blah, blah, blah. But when you're dealing with numbers like this, the estimation can help recognize when, oh, wait a minute, that doesn't, it seems right, but then when you start thinking about it, like, that doesn't seem right because my number would be too big. Again, we come back up.
Yeah, I started overthinking it.
Yep, we come back up and do the count. There's 1, there's 2. This one has nothing behind a decimal. There's no decimal there at all. So we just have the 1 and the 2, which means it's the 1 and the 2. This one's my favorite. Where's my decimal go?
In front of the 4.
Okay.
Nope, because there's a 0 before the 4 because that has to have 5 places.
Okay.
That would probably be correct because they're both less than whole numbers, so it's going to be a really small number.
Okay. I love to hear you guys logic your way through it. I really do. That's the thing. I wish I could get my day job students to think more logically about math.
How old are they?
It's still a demon. I don't like it.
I know, and that's the thing. My day job students are 10.
Oh no.
That makes me feel so much better. Thank you.
But I mean, I'm also only asking them to do 10-year-old math. So, but there's.
Well, you're asking us to do 10-year-old math. So how does that make me feel at 40?
Well,
I was going to say it took me at least until I was like 21 to even gain common sense. So
I couldn't do this at 23.
But that's what I'm saying. There is so much logical about math. Now, I recognize as I work with my 10-year-olds, they're not at the point where they're going to grasp most of the logic. Every once in a while, yeah, it'll click for a couple of them.
I don't grasp most of the logic. I'm 40.
But, and that's the thing. But I loved hearing both of you just now logic your way through it. Because there is a logic in math. They're really not trying to trick you. I mean, it feels that way. Sometimes a lot it feels that way. But they're really not trying to trick you. But so you're both right. Our problem has 5. Our answer has 4. We solve that by putting a 0 at the front and then putting the decimal point. So nicely done on that. Now let's get into the dividing, and we're going to have to work quickly. So there's three points to our division problem. There's the divisor, the dividend, and the quotient. The divisor is what's outside. The way I always used to confuse these two. The way I remember that the one underneath is the dividend is if you look, the word dividend, it
says divide right in it.
Oh, that's actually funny. That's not what I ever noticed about it. What I noticed about it was this, and end. It's the end of that number because we're breaking it apart. The divisor, we're not ending that number. We're just ending this one. Anyway, it makes sense in my head, which doesn't mean anything.
I'll go with you on it.
See, there you go. So there's a couple of different types of division problems you'll run into that involve decimals. The first kind has just one decimal, and it's right underneath, right there. And those are the easiest ones to deal with, I think. You simply bring the decimal straight up, and then you divide like normal. So 2 goes into 7 3 times. 1 left over, bring the 3 down. 2 goes into 13 6 times. It's 12. 1 left over, bring down the 8. 2 goes into 18 9 times. It is 18. Bring down the 8. 2 goes into 8.
Irma,
Oh,
could you please meet Miss Mercy in the gym?
Sorry.
I love it.
Awesome. Yay, Irma.
Yeah,
You live in Texas for real.
I do. Irma is our fantastic janitor at my school. Who
Yay, Irma.
trying to get as much done before academic night as she can. And then we're going to make a giant mess out of everything for her. God bless her. She's a sweet woman. 2 goes into 8. 4 times it is 8. Bring down the 6. 2 goes into 6. 3 times it's 6. And we're done. The decimal is already in place. There's no counting. There's no shifting. You put it, you move it up, you work, you're done. Okay? So now's where we play beat the teacher. There's the problem. The way you play beat the teacher is simple. I say go, and you both have to solve that problem before I solve that problem.
Oh, yeah, right.
No, we can do this. I'm gonna give you a head start while I walk over and get my drink. So, on your mark, get set, go.
Okay, 3 will go into 7 twice,
No.
so that's a 2.
No, yes, but you gotta. You
Okay.
can't give me the answers.
Well, why
The
not?
answer,
You
because
said
then
I had to do it faster than you.
well, right, but if you do it with me, you're just gonna. Then there's not faster. There's just done at the same time. I got to get my Post-it note and go to work.
Okay, whatever.
Okay, go. Ready, go.
I got it.
Dang it. I just got my drink. Okay, wait.
Well, let's see if I'm right.
Well, I'm not done yet. Let me finish. Hang on. Because if you're wrong, then I could still win.
If I can read my own handwriting.
All right. Are we ready, ladies?
I
Yes.
think so.
I think I lost, which I'm not gonna lie, I don't often lose this game.
Well, way to go. I'm glad you lost then.
Well, I think I lost. Here we go. Our answer is 246.29. 246 and 29 hundredths.
I'm going to be completely honest. No.
Oh.
I lost then.
Well, there you go. Do you spot your mistake?
Yes, I did it too fast and I can't read my own handwriting. I changed one of the numbers.
That's why this, and I said this at the beginning, Brenda wasn't here yet, but I did add that caveat. This is a horrible, horrible game because you shouldn't rush math. But it's entertaining, so we do it anyway.
See, I let my number dyslexia get in the way. I put 283, or no, 783.87.
Yeah.
I was like, wait a minute.
All right, so here's the second type of problem you're going to run into. And it is when you have a decimal in the divisor and in the dividend.
No.
The problem is, and
I
this is-
hate those.
I know, but they're easier
They are
to
not
solve.
my friend.
But I know, but they're really, I promise, they're easier to solve than you think. You ready?
If I have to.
Here's the problem. You're not allowed to have one here. Now it's maths, so we can't just take it. We want to, but we can't just take it. So what we're going to do is we're going to multiply 0.23 or 23 hundredths. We're going to multiply it by 10. And when we multiply 23 hundredths times 10, we're going to get 2 3/10. So now we're going to multiply it by 10 again, and we're going to get 23.
Whatever you do outside, don't you have to do inside?
Yes, which means I have to multiply 5 888 thousandths times 10, and then times 10 again, so that I can move it. Now, I just told you the mathematical reasoning for what you're doing. Because,
And I'm still lost.
well, here's the short version. Are you ready?
Sure. Enlighten me.
Look at the number outside the decimal. I mean,
Okay.
outside the box. Take the decimal and move it to the right until you're at the end of the number.
Okay.
So I go 1, 2 places. Now
So
I'm
then
at
I do that again on the inside.
Now you do it on the inside. 1, 2 places. You move that decimal point straight up, and you solve. Bring down the 8. It's going to go in 5 times, 115. Bring down the 8 again. It's going to go in 6 times. It is 138. Okay.
Now you move the decimal point back?
Nope.
Nope.
Nope. We already did it.
Okay.
That's
Why would?
what
Sorry.
now?
I just don't understand why we don't move it back, but that's okay. I'll just trust your judgment on that.
Well, so that's where you get back into the mathematical reason for why we moved it in the first place.
You can't divide by less than 1?
You can.
For all intents and purposes, for this reasoning, you can't.
Right. You can.
This is the mother's law because I said so.
Right. And so
There you go.
what we're doing is
Good logic. I
instead
like mother laws.
of dividing 5 and 888 thousandths by 2300ths, we're finding two compatible numbers. We're doing that by multiplying them by 10, right? If I have 25 divided by 5, what's the answer?
5.
Right? Okay, now what if I multiply each of those numbers by 10 and then divide? What if I take 25 and multiply it by 10 to get 250, and I take 5 and multiply it by 10 to get 50? So now I'm dividing, instead of 25 by 5, I'm dividing 250 by 50.
And my brain already hurt, so just stop.
The answer will be 5.
It's still going to be the same because basically 10 is just going to give you placeholders.
Yep.
Only this is less confusing.
Right, which is why I don't often explain it. I just tell you to move the decimal point.
Well, that makes more sense, and it's easier to comprehend.
Yeah, but that's why you don't have to move it back.
Okay.
Because what we've done is we found numbers that are compatible.
Okay.
And in finding numbers that are compatible, it's going to give us the
Basically,
same.
the number larger to make it have more sense.
Yes. That's all we've done.
Okay.
So move the decimal and then leave it.
Okay.
Don't move it back. That's the short version. All right. So remainders, this is the last way you're going to see it. You're going to have a problem like 347 divided by 5, and you're going to get to the end of it, and you're going to have a remainder. And this is where we have to remember that really there's always a decimal point there, even though we don't see it. Last week we said do remainder 2. From now forward, it's add the decimal point, add a 0, and keep working. 5 goes into 20 4 times. That's your answer. Okay.
Okay.
Which again, this one, most of us just do it anyway because it's what we've done the longest in our life. Remainders tends to be more confusing for people because it's not what we've been doing our whole life. We stopped doing it in like 6th grade. And then our teacher would yell at us every time we tried to use a remainder. No, use a decimal. Stop using a remainder. Ooh, I got yelled at for that.
Keep solving until you get to 0.
Uh-huh. No, yeah. I hated it.
I hated that.
And yet, because it's what we all heard and because it's what we all got yelled at for, here I am 30 years later, and I have to remind myself.
Teacher,
Oh,
we
shoot.
will give you an all call when the pizza gets here, but it has not arrived yet. So sorry.
Awesome.
Sorry for these interruptions. Clearly, if I had known they were coming, I would have, I don't know, done something different. Oh, geez.
It's
It makes
okay.
it funner. It's all good. No worries.
Yep.
It's entertaining anyway.
Yeah. Mr. Lewis to the science lab. If they call me, I'm going to be laughing. All right, averages. So here's where we're at with averages. Averages, the other mathematical name for it is mean. Now, this is not one of those situations where average is an incorrect mathematical name. It's not. This is just one of those concepts that has two names. Your homework is going to ask you for mean. It's going to ask you to identify the mean of a number. Okay? Basically what it is, you're given a data set. Pardon me. In other words, you're given a group of numbers. And they want to know what's the average value, right? We find that by first adding all the numbers up. So 4 plus 5 plus 2 plus 8 plus 6 plus 1 plus 9, which gets us 35. And then we divide the sum, so we divide that 35 by how many numbers were in our data set. So we had 1, 2, 3, 4, 5, 6,
7.
7. So we're going to divide 35 by 7, and that is going to be our average. Now, here's the thing that I want you to understand. Well, not understand. It's a little help for you. It's not going to guarantee you found the right answer, but if you look at it and if you get used to seeing or looking for it, you'll know if your answer's way wrong. Your average is always going to fall in between the highest and the lowest number. So in this data set, my high number is a 9. My low number is a 1. My average has to be in between 1 and 9. Now, where it falls just depends on how the numbers are spread out. These ones are kind of spread out all over, which is why it tends to sit about in the middle. But if all of these were 8s and then a 1 and a 9, my average would probably be closer to 9 than it would 1. If all of these were 1 and then a 9, my average would be closer to 1 than it would 9. But it's always going to fall in between. So if you're solving and this is your data set and you get an answer of 13, you know you've done something wrong because it's not falling in between, which is what it has to do. So this one, we're not going to play Beat the Teacher. But what's the first thing I'm going to do here?
You're going to add them all together.
Okay.
So 5 plus 4 plus 12 plus 2 plus 1 plus 6 plus 7 plus 3 plus 10 plus 1 plus 4.
And when I do that, I find that my answer is 55.
55.
Now what do I do?
Divide by however many numbers you have.
And how many do I have?
11.
And so my average is?
5.
There it is. That's it. It's just that simple. Now, the numbers you'll be dealing with will be larger, but there will be fewer of them. I don't think on your homework you're going to have more than 4 numbers to deal with. But they will, I think, all of them be above 50. A couple of them in the hundreds. So you'll have it, but it's a fairly simple, right? You add and then you divide. And then you've got your answer. Sometimes your average is going to involve a decimal. That's fine. It can. The general rule, if you're trying to work a number, round to the nearest hundredth. Unless you're specifically told something else. If you're specifically told something else, do what you're told. But if you're not and you're working a number and you get out to the thousandths, yeah, go ahead and stop and round it to the nearest hundredth and call it good. All right. Here's a couple of tips. One of them is super ironic given the games we played tonight. Speed is not your friend, right? We discovered that working or playing Beat the Teacher.
I don't want to talk about it.
You have to have counseling now.
We tend to make silly mistakes when we rush. We miss a word, we miscopy a number, right? That's one of the ones I do. I'll miscopy signs.
Suddenly develop dyslexia.
Yeah. So, I mean, you know, speed's not your friend, and you don't get bonus points for finishing first. I've had times where I'll see a score on an assignment, and then I'll look at how long it took them to do the assignment, and they were spending not even 30 seconds on each question. And, well, yeah, now I get how come the score is low, because when you're spending 30 seconds a question, you're not writing anything out. You're doing it all in your head. Mistakes are going to abound at that point. So it's just something you want to watch. My last tip for you goes back to doing it in your head. Yes, there's a lot of math we can do in our head. Don't. Write it down. I still, and that's the thing. You're like, well, of course you do. You're the teacher. You have to model it. No, I don't. Even when I am just doing it right, every once in a while, yes, I realize I'm about to show how much of a dork I am. But even when I'm working with my, like every once in a while, I'll do the assignment that I give my students. Like I'll just do it and create an answer key. Not that the book has the answer key, but I'll still create the answer key just because I like to do the math. I still show my work, even when I'm working by myself, even when no one's going to see it, because it helps me spot mistakes I make, right? And I still make mistakes. I mean, we all still make mistakes.
I had a teacher tell me once, don't hang out in your head where there's no adult supervision.
That's good logic there.
Yeah,
She
see?
said, and it applies to any age.
Safer.
It doesn't matter if you're a teacher, if you're anybody. Don't hang around in your head too long because there's no adult supervision.
Yeah.
If you have ideas, bounce it off of other people or write it down because there's nobody up there to tell you if you're doing it right or if you're doing it wrong. Just write it down.
Yep. And that's what we need to remember. All right. Here's my closing thoughts for you. Assignments are due Saturday, February 27th at 11:59 Mountain Standard. If you go back and maybe you want more points on an assignment, or maybe you want more points on a discussion, that's fine. The assignments will auto update. Those scores will on the math assignments. The discussions won't. And the problem is, if I've already scored you something other than a 0, it's not going to tell me that you went back in and did stuff. So if you decide to go back and try to earn some extra points, which is great, that's just fine with me. Please let me know that you've done it so I can go back and actually award you points, because there's no guarantee it happens otherwise.
That's awesome. I didn't even know I could do that.
Yeah, I mean,
Not that I make it a habit,
I was
but
gonna
that's
say, I don't know how much you can in your other classes. We have a little more leeway in this class, which lets us get away with some stuff.
I'm okay with that.
Yeah, me too.
I like getting most stuff.
Yeah. Friends, you've made it to the halfway point, and you're doing very well. I love reading your discussions. I really do. I'm seeing some uses of math crop up last week and that I haven't seen before, which I love. I love finding people's new uses of math. So that's
Hair dye measurements.
yeah, that one actually has come up before. I wasn't sure about it, but it's come up. Anyway, my friends, thanks for coming. Thanks for being my guinea pigs and taking the brunt of my inappropriate games. My teacher, which is a horrible, horrible game, and you played it anyway.
Tell Irma we said hi.
I will tell everyone you said hi. And that's our show for tonight, my friend.
Tell her thanks for doing the good job, and if she needs a puppy, I've got one.
I'm sure she does not need a puppy.
I can ship it to Texas.
Poke holes in the box.
Doesn't your daughter still need a puppy?
No, my daughter does not need a
She
puppy.
would love these puppies. They're so cute.
Would, and she would. And no.
Then you can count the poop piles you'd be picking up.
Oh no. I'm going to stop our recording, but thanks for coming, ladies. Have a good night.